Welcome to the walkthrough of Assignment 2B in my Scalable Microservices classes in the spring of 2024. The purpose of the second part of this assignment is to deepen your understanding of how to develop multiple synchronous microservices with Spring WebMVC, the Eureka Discovery Service, the Spring Cloud Gateway, the Retrofit TypeSafe Client API, and the Jakarta Persistence API, also known as the JPA. In this assignment, you'll apply the JPA to create a database that stores information about movies and supports various SQL queries, including a custom SQL query, as well as apply Retrofit to create several TypeSafe client APIs that access database and timer microservices via an API gateway. The code you write for this assignment doesn't have a GUI and runs as a Spring application with an integration main program. Please feel free to use this main program to help debug your solution. The following resources may be helpful in completing this assignment. A tutorial on the JPA appears here, a tutorial on Retrofit appears here, and I recommend you use ChatGPT whenever you can to help learn and code these various APIs. Naturally, we'll cover all this material in class, which will be available in my YouTube playlist as usual. The database microservice is packaged as a project using IntelliJ. This app is written in Java and demonstrates various Spring WebMVC and Java concurrency and persistence features. For the purposes of Assignment 2B, however, just focus on the following directories. Client, which is in the client module, which contains a client main driver program containing proxy skeletons you'll need to fill in, as described below. And database, in the database module, which contains the database microservice server skeletons you need to fill in, as also described below. You'll also need to copy the synchronous movie EX microservice implementation from Assignment 2A, which is found in these folders in the Movies EX module. Movies EX, which contains the skeletons you need to fill in, is described below, and Movies EX source test, which is a set of unit tests that exercise the features you're implementing to evaluate whether you've correctly satisfied this earlier assignment's requirements. You'll need to modify several files containing the skeleton Java code by completing the to-do you fill in here task to provide a working solution. Don't change the overall structure of the skeleton, just fill in the to-do tasks, and whatever you do, do not delete the to-do markers or your submission will not be reviewed. In particular, you'll need to finish implementing the to-do tasks for this assignment in the following files and folders. Client, where you need to complete the to-do tasks in various fields and methods to implement a type-safe client using Retrofit and a proxy that encapsulates it. Database, where you need to complete the to-do tasks in various fields and methods of the multi-query repository impl.java and database service.java files that use declarative and programmatic features of the Jakarta Persistence API together with Java parallel streams to return lists of objects containing information about movies. You'll also need to complete the to-do tasks and factor methods in the serverbeans.java and clientbeans.java files that can be injected into Java classes using the Spring auto-wired annotation. Finally, you need to implement the to-do tasks in the movie.java file, which is in a different location. It's over in the common module, and we'll look at that when we walk through the skeletons here shortly. As usual, your solution should strive to use few, if any, loops or if-else statements, and instead use Java functional programming features such as lambda expressions, method references, and parallel stream aggregate operations. Your solution will be considered correct if it passes all the unit tests, is commented thoroughly, and addresses my review comments. Solutions that are not commented thoroughly will not be reviewed. The skeleton code for this assignment is available here in my GitHub repository. Please pull the skeleton code into your GitLab repository, read it carefully, and complete the to-do tasks. They're unit tests that exercise all the to-do tasks you must complete. To compile and run these tests, you need to use the provided IntelliJ project. You can run all the unit tests by opening the Gradle tab, followed by navigating down to the Tasks Verification Check submenu. At that point, all you need to do is double-click on the Check submenu, and all the tests will build and run automatically, which is much simpler than what we did in previous assignments. As always, these tests increase our collective confidence your solution is working as expected. As always, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on the test to detect problems in your code. In particular, I'll also provide videos that walk through frequently made mistakes that you need to address. Please address these issues prior to your submissions to streamline our programming assignment review and assessment process. Assignment 2B is designed to further deepen your understanding of developing multiple synchronous microservices using Spring WebMVC, the Eureka Discovery Service, the Spring Cloud Gateway, the Retrofit TypeSafe Client API, and the Jakarta Persistence API. The skeletons and tests are quite extensive, though you don't need to understand them all to complete your solution. This assignment is a bit more complicated than Assignment 2A, so please start early and ask questions in class, office hours, and on the discussion forums to ensure you complete this assignment successfully. Now that we've walked through the specification for assignment 2B, let's go ahead and take a look at the skeletons. If you open the project here, you'll see that there's some new modules, one of which is a testing module, which consolidates a lot of our test framework. You don't have to worry about that. That's done for you. There's also a gateway and Eureka module. Those modules are also provided for you. You don't have to do anything with them, although we'll talk in class after the break about cool ways we're using Eureka more effectively now in this new version of the assignment. There's also a MovieZX module, and this is basically where you're going to need to go in and essentially kind of cut and paste what you did before with respect to the movies service and movies controller files, as well as the server beans, as well as also going over to the tests and updating the movie sync proxy. So that's pretty much the same as we did before. So I'm not going to dwell on that at any length now. You can go back and watch the walkthrough videos for assignment 2A to get a sense of what you need to do there. But that should just be a simple matter of cutting and pasting. Things are a little bit more interesting in some of the other modules, but before we get there, there's also a timer module, which you also don't have to do anything with. That's used by the database module we'll talk about in a second. Now, there are some new modules that you do need to be concerned about, one of which is called Common. And Common factors out common code that we share between various microservices. In particular, here's the movie class, and this movie class is something you need to implement based on what you did for assignment 2A. We just moved where it is now. And so if you'll see here, you have to implement the interface that the movie class is going to implement. And then you also have to come down here and implement 3 methods. You have to implement a compare to method, an equals method, and a hash code method. These should be similar to what you did before. The hash code method is new from last assignment, although some of you did it anyway, which was good. And this is very important in order to be able to get the parallel streams to work properly. And we'll talk more about that in just a moment. So make sure that you go ahead and implement these methods. Make sure you take a look at the frequently made mistakes video to get some hints. And ChatGPT also should be able to help you out there as well. So that's what you have to do in Common. So don't overlook the to-dos in Common. The other places you'll have to have to-dos are the client module and the database module. So let's take a look at the client module first. So in the client module, if you come down here, you'll see that there's a couple of places you have to either re-implement or update your code from assignment 2A. One of them is client beans, where you have to implement the get rest template bean. Make sure you do that properly. And then you also have to implement the get database API and get timing API methods as well. These are factor methods that are beans. They should be very, very similar to what you had in your assignment that you did before. So please make sure that you handle those things properly. If we come over here to the client folder, you'll see we have the database API, which is the retrofit code. And just make sure that you've addressed the comments I had in the frequently made mistakes video. There were a lot of mistakes here, so please be careful. If you don't get this stuff right, your program just won't work. There's also a timer API. Most people did pretty good job with the timer API, so I wouldn't worry too much about that, but make sure you get that working correctly. And then some places you'll have to do some modifications here are database sync proxy and timer sync proxy. So let's go ahead and take a look at database sync proxy. The main thing you're going to do here is you're going to leverage this utility class that I've developed called call utils, which factors out all the code for checking whether the result of a call is executed properly. And so you'll be able to greatly clean up the code here by using that. And so I just want you to get in the habit of using refactored code. And the same thing is true for this timer sync proxy as well. So that should also be done the same way. So not a lot of changes to client, just a few kind of cleanup type things. Now let's go over here and take a look at the database module. So a lot of stuff here is also very similar, although we've added a few things and refactored a few things just to make it a little cleaner. So here's the server beans implementation. You really don't have to do much here except to make this a bean, which I think you hopefully know how to do by now. And so that's all you have to do there. Now let's go ahead and take a look at some of the changes to the server portion. So let's first take a look at how we've refactored the database controller. So database controller is now split up into 2 files, one of which has got the database controller methods that are not timed. So these are what we had before. And now we have a new file that's called database controller timed. And as you can see, we basically map all the timed requests to it. And this has 3 methods in it that are the timed methods. And this is super cool, super clean, very nicely refactored to make the code easier to read. And it also demonstrates how you can actually have multiple controllers in the same application that don't inherit from each other, but that provide different endpoint handler methods. And Spring can keep track of all this stuff, and it all works very nicely and cleanly. So that's a cool little feature. Now let's take a look at database repository. Here we have a slight change. It implements or extends the JPA repository like it did before, but now it also extends multi-query repository. And we've talked about this in some of our discussions in class, so this should not be new. But you'll have to just implement the JPA repository methods here, these 2. Make sure you use the right Spring Data API keywords in the names in order to get them to do the things that need to be done. You do not need to write any implementations of these methods. You just have to define them using the Spring Data API keywords properly. Now let's go take a look at multi-query repository. This is defining the interface that we're going to be implementing, which will basically be used to find all the movies by the ID that contain containing in, and that basically means it's going to take a list, and it's going to look for all the matches, and they all have to match. And this will be ordered by ascending order by the movie titles, the IDs. So that's the name of the method. Now, there's no way to get Spring Data API to generate this query for us automatically. So we're going to implement our own version that does this in the multi-query repository impl file. And you'll see here that we've got 3 methods you have to implement. And this is actually very similar to what we've gone over in class as some examples showing how to use the entity manager and showing how to use criteria builder and criteria query and so on in order to be able to set up your own custom SQL query. So this kind of gives you some tips on what to do. If you look at the other examples we've got, it's very similar to what's done there, just customized for this particular application using movies as opposed to quotes, for example. And then you have to make some calls to some helper methods. And one of the methods is called getPredicate. And what you'll do here is you'll use a Java sequential stream to build a predicate that ands all the lowercase queries together. So we have a list of queries, and you're going to make this predicate that's going to and them all together. And once again, if you go and you take a look at the quotes example, which is in my WebMVC EX4 folder, you'll get a chance to see kind of what this should look like. And so that'll build the predicate. And then the other helper method here is called getQueryResults. And getQueryResults is going to be used in order to be able to perform the query and return the results. And this is a little bit more tricky. It's a little bit trickier than the example I showed in class deliberately, because I wanted you to have something where you have to figure out how to do this. And so what you'll need to do here is you'll have to use these various explicit JPA programming mechanisms like the criteria builder and the criteria query and so on to create and execute a query that returns a list of non-duplicate movie objects ordered by the movie title, the ID field, in ascending order, where the movie's ID field contains all the given queries. And of course, that'll be what's provided by this and predicate that you build with this factory method right here. So this is a little bit trickier. I recommend you take a look at what I've done, and then feel free to use ChatGPT to try to flesh out some additional ways of doing the other parts, like sorting it in the right order, as well as also ensuring that there are distinct entities, non-duplicates in the query. So that's going to take a little bit of doing, but luckily we have some good test cases that'll help you along the way. Now let's turn our attention to the database service implementation. So a couple of these methods are just forwarding to the repository. The getMovies method just forwards to the appropriate method in the repository. And the search method that takes a query string also does the same thing. Then we have 2 other methods. We have search and we have searchEX. The search method that takes a list of queries is going to use Java parallel streams and a sequential stream and the Jakarta persistence API to locate all the movies whose ID matches the list of queries and returns them as a list of movie objects. Now, really the JPA thing here is just calling one of the methods in the repository that you define. So just calling one of those things. This will look very much like what you did for assignment 2A. But now that you've added in the hash code method in the movie class, you'll be able to finally use a parallel stream in a clean way without having to break this up into a parallel part and a sequential part. So you can actually use parallel streams, use a parallel stream at the outer level, and then just kind of chain all those things together. And you can use things like sorted and distinct and toList. So that's the approach I prefer that you use. The tests will kind of check for that. Using the tree set approach is probably not the best approach here because you have to convert it back into a list in order to return it as the results for search. It turns out, by the way, under the hood, that Java Streams uses a hash set in order to be able to get rid of duplicate entries. So if you use the streams approach, or when you use the streams approach, you actually will, in fact, be using a set under the hood. You just won't see it because it's hidden by the distinct method. And then the fourth and final method here is one where you just forward to the corresponding method here in multi-query repository impl, basically, to this guy. And so you'll just go ahead and forward that from this method in the database service. So this is going to be one that's going to return everything that matches all the queries, whereas this method is going to return movies that match any of the queries, or at least one of the queries. So I think that is basically the walkthrough for this assignment. Most things are similar to assignment 2A, just a little refactoring and cleaning up. But the big change is this method here, the find all by ID containing in order by ascend method. And that's the one that's primarily going to take some time to puzzle out. So that's the main enhancement for this assignment 2B. And of course, everything needs to pass all the tests. And of course, we're going to show how to run the tests in the next part of this video. Now that we've walked through the specification and skeletons, let's take a look at running the tests, which have been greatly streamlined for assignment 2B. All you need to do is go open the Gradle tab, click on assignment 2, click on tasks, click on verification, and then click on check, and then double click on check. And that will go ahead and instantiate and run all the tests in one fell swoop. Moreover, you don't have to go and start up any background processes running the various microservices. We've written tests to do all the testing using various white box and or black box techniques. So the end result is very, very straightforward to test. Now, the downside, or potentially the downside, is we have a lot more tests than we did before. And so those tests take a while to run. But what they'll do is they'll exercise all the various features under test in your assignment. So you can see here that we go ahead and run a bunch of API tests. We run a bunch of sync proxy tests. We run tests on the timing sync proxy. We test your client beans. We test your movies. We test the database tests. And then we come down here and you can see some more tests that are being done here for the database repository and the database service and so on and so forth. So when all is said and done, there'll be a lot of tests that are run. And this can take a little while, especially if you're running on a slower machine. But the good news is when everything's finished, you should see a nice little sea of green here. And if things are going wrong, you can come in and check to see what's been going wrong and why they've been going wrong. So as usual, it's your responsibility to make sure all of these tests pass, but it's a lot easier than it was in the previous versions of the assignment because we've consolidated all the tests in one place.